Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Last night I had a visitor. It was a friend of mine, Mike. He's a longtime viewer of the channel. He started viewing my channel back when I had like 1,000 subscribers when I was a really small time. And he's brought me a lot of equipment in the past too to repair, and developed a little bit of a relationship where he knows and I know what he needs and he knows what I do. So that's good. But he brought me this. He says he was... This is, I'll tell you a little story behind this. This is a Nakamichi Receiver 3. He was telling me the story behind this one is he loaned this out to his father, and his father used it for a while, and then I think it sat in a closet for a number of years. I'm not sure how long, but then he got it back from his father, and then he tried listening to it, and he said it sounded really terrible in the sense that it had no bass. And it just didn't have any clarity and any definition, like it sounded muddy. So he brought it to me. He thinks I can do something with it. I think I can. I did connect this up and listen to it a little bit today, just for maybe 20 minutes or so. It does sound okay with regards to the bass. It does have bass. He says he had to crank the bass up before it would sound anything, but I think it's working. I did notice that it doesn't sound good at all. It sounds really hollow, and I had to crank the balance. I had to put the balance in about the 11 o'clock position to get a balanced sound out of both speakers. Like, sounded like the left channel was weak and really not there. It was there, but it just really sounded kind of feeble. And the right channel was kind of overpowering the left channel. So that's why I said, you put it at 11 o'clock position, it sounded more balanced. But it still didn't sound good. The bass was sounding fine, like the level of bass, and it sounded that sounded okay. But it just sounded like bleh. So what I did is I took it some time this morning, and I put it on the bench, and I did some analysis of what it is here right now. Distortion is not good. We have up in the left channel we have up to 0.4%, and in the right channel we got about 1/4%. And the spec for this receiver distortion is let's see here, is less than 0.1%. Okay, but we're way over that on both channels. The frequency response is 20 to 20 kilohertz plus or minus 1 dB. And we're barely in that spec. We are at, let's see, 0 at 1,000 hertz. But when we drop down to 20 hertz, we drop almost at 1 dB. And then when we get up to 20 kilohertz, we are down 0.3, 0.6 dB. If I go to 30 kilohertz, it's worse. We're down to 1 dB on the right channel. So the frequency response isn't the greatest. Distortion is terrible, and I kind of have an idea of what's going on here. I think it's just a dirty relay, because the distortion tests, the needle was jumping all over the place, and that's indication of either a dirty switch, dirty connection, dirty relay, something that's weak in the chain that's letting go and not passing the signal through. He brought it to me. He wants me to do my full service, which includes a full recap and tune-up and everything else, and inspection of all the boards and resoldering everything. So we're going to get started on that right now. But first, let's hook it up and let's look at some square waves to see if we can pinpoint anything else. Alright, I think the best way to visualize what I'm hearing is just maybe feed some square waves through this, and if we can see anything on the screen. So let's do that. I got my scope hooked up. Let's turn this on. And we are on CD. I do believe there's the relay click. Okay. I'll turn the speakers on, would help. Okay, so here is... let me get my probes going correctly here. Let's... Okay, so if we turn this up, we should be able to see our left and right. We don't have don't have the same amplitude on left and right. If I go down, well, maybe it's close. It's very close. So what else is going on here? The left is kind of twitching. I don't know what's going on with that. It's going to crack solder joint. But anyways, if I put the balance control at about 11 o'clock, that's where it sounds the best. You can see that the right drops a little bit. So this looks not bad so far. So here's bass cut. Oh, we got no tone controls. What's going on here? Bass cut. Oh, there's. So really, I think the potentiometers in this thing are fried. Maybe that's because I got no range of control here until I get about at the 9 o'clock position, and then yeah, I don't know what's going on with these. And bass boost. I got no range of control between 9 and 3 o'clock. Right? You can swing it back and forth. This is a 1000 hertz tone. Let's do treble. Treble cut. Treble boost. That's working fine. Loudness. That's fine. Something weird with this bass pot. Now he did complain that it sounded like it had no bass to it. And I just had this hooked up on the listening bench, and it sounded fine to me. It had the correct amount of bass, and everything was balanced. But it sounded kind of, I don't know. It just didn't have any depth to the. Oh, what's going on here now? Something changed. I wasn't even watching the scope, and then I look up and I see this. So what is going on with this amplifier? Oh, okay, that's a loudness switch. So maybe we just got a funky loudness switch. It's dirty. Look at how dirty that is. It's very touchy if I play with it. Yeah, we got a bad loudness switch. That's dirty. Okay, we can fix that. But this bass pot thing's got me. Alright, so let's go down in frequency and check our low end. Let's go down to 100 hertz. Yeah. Kind of okay, I guess. It's got a lot of tilt at 100 hertz, that's for sure. So we're missing some frequency response at the low end. Let's go down farther. Let's go to 30 hertz. Yeah, and we're still. It's not looking good at all. I've seen a lot better. Let's go down 20, 10 hertz. Okay. And see how this looks on the high end. 10. That's 10 kilohertz. It's not bad. We lose it somewhere around here. Yeah, it's not very. It's 22 kilohertz here, but 18 kilohertz there. So yeah, it's not the. There's something that's lacking in this amplifier. All right, screws are out. Let's take a look. It's nice and clean underneath. Doesn't look that dirty. He said it was all dirty, and I don't think it's that bad. I think it's got some dust in it. I can pull that up. Yeah. So we got a bit of a heat zone right here. It's kind of scorched. I don't know what they're doing with this. But doesn't look like they have great caps in this thing. It looks like they used some no-name capacitors. I don't see anything leaking or anything that way. But yeah, we're gonna go through this and fix it all up. We're gonna replace all these caps. So this relay, I suspect this relay is bad with high contact resistance. That's why we're getting the high distortion readings. And that's just a simple matter of opening it up, cleaning it, and that should just go away. The distortion should go away if that's the case. And it should drop to a reasonable value. So this is a remote unit, and it has a motorized volume control. And here's a lithium battery for backup of the memory. So I have to make sure that's still alive. If that's dead, we'll replace that. Cute little transformer. I don't think this is very high power. What do we have here? 37 watts a channel. Dynamic output 55 watts per channel to 8 ohms. Well, we'll measure all that. Power bandwidth. Output current capability 10 amps peak per channel. Yeah, it looks okay. Everything's here. I'm going to blow this out and it'll look a little better. Got kind of a unique heat sink here. It's extruded and then it's got these attached fins. The dust. I'll pull the bottom off, have a look there too. A little access panel here. I'm not a big fan of these because it only allows you access over the amplifier section. And all of the tuner is still all blocked. So I'm going to do a recap of the tuner and everything. I have to pull the main board anyway. So it's all going to come apart. Yeah. Everything looks good here. I don't see anything wrong with any of the solder, but then I just started looking, so this looks all fine. Yeah, okay. Well, I'll get started doing my thing. I'll just assemble it. So I think I'm just going to have to pull the main board out. So it's going to have to all come apart anyway, so I'll just start attacking it, taking screws out. Let's see here. There's no connectors on here. This is the pain. Some of these have connectors, but some don't. But we'll work through it. Okay, just going through and doing some initial checks. A lot of these Taiwanese caps are doing okay. Like for example, in the tuner, they're still holding up their values and they're still doing their job. Phono stage as well. They're okay, but for the most part. And then when you get around this area here, they start to sag. The values are dropping quite a bit. Yeah, I think this is just going to get a full recap. A lot of this part here is where the problem is with the caps. Can't really tell anything else about. I haven't pulled a relay yet, so I don't know. So this could be a chore to get this main board out, and I guess I have to leave everything attached, like all these wiring. Some of these you can disconnect, but most of it just stays attached. Like this speaker wiring here from the relay goes to the switch, and then it comes back to the back panel here. So that can all stay connected. I just have to, I guess I have to pull transistors out, pull the screws. Yeah, I think I'll just lay the main board down and I can do all the recapping. I want to do the tuners as well. I think these caps, I don't know how old everything is in here. Let's have a look for some date codes. I don't see any date codes here. It's hard to say. I don't see any date codes. I don't know what year this thing was built. And there's nothing on the back. Made in Taiwan, Republic of China. Yeah. It's too bad they didn't build this thing in Japan. Alright, here's a look at the relay. So this is one side. 150 ohms. Try that again. 7 ohms. 65 ohms. Yeah, this relay is not very good shape right now. I have to definitely clean it. Let's try the other channel. Try the other channel quick here. Let's see. 3 ohms. 15, and it's not consistent either, so 2 ohms, 11. Yeah, like that's exactly what I thought was wrong with this thing, is the relay is pooched. Yeah, and I don't know, I might have to replace this. This is a 24-volt relay, and the only way in is through the top. So let's see if we get the lid off this thing. Problem is I get the top off, but then how do you get in to clean it? So let's see if we can get into this thing and figure out. Yeah, see, our contacts are buried down inside there. I probably could get some sandpaper in there. I think that's what I'll do, is I'll get a strip of sandpaper probably about 3 millimeters wide, and I'll slip it down inside there where the contacts are, and then close it with some electricity, put some power to this, close it, and I think I can close it on the other way. Oh, you can close it that way. I'll see what I can do with this. If I can, I'm going to have to replace it. 5 amps. I always rag on about stuff made in China. This is the reason why. This is pretty shocking build quality here. This is the Zobel network on the right channel, and it was never even soldered at the factory. It got through quality control, and this is the way it was when I found it. Okay, sorry, my mistake. That was not the Zobel network. This is the output of the amplifier. Goes through the resistor and inductor, and then out to this relay. So this is the resistor that was open, R330 right. So this one had a coil, but no resistor. This one had both. So is that enough to upset the listening experience and make this thing sound like crap? I think it might be. Well, they're only 1.8 microhenries, but they're still enough to maybe kill some of the highs. But yeah, this resistor was not even soldered. So how about that? Alright, so I just finished doing the recapping, and that went well. I didn't really find bad caps in this thing. They were actually surprised. They were holding up pretty good. A lot of them showed a little bit degradation in their value, but it wasn't enough to create the sound problem this thing has. You know, with a flat sounding sound with no depth or anything. Like, I think there's something else going on with this. We might have bad transistor or something going on in there. Next, I'm going to scrutinize the bass and treble pots. I want to take this bass pot apart and give it a physical cleaning and relubrication. It's going to pull that out next, and then I'm also going to do these switches as well. They need, this loudness switch especially is bad, and then I'm going to clean both speaker switches, because I think we have a high resistance problem. We found a high resistance problem with the relay, and I also think there's a problem with those switches, so I'm going to do those as well while I have everything apart, and we're going to make sure that it's all 100% before we put it back together. Alright, so here's the bass pot, and this is a double pot. It's got 6 pins on the bottom. Pretty easy to service these. You just bend back the tangs on the back here, straighten them out, and it should all fall apart. The reason I want to go after this is because it's got some non-linear characteristics when you're going through the range, and it didn't seem like it was very good. So here we go. We got our wipers on the bottom. Right in the center there's a post that fits in this hole, and there's 2 wipers right on either side of the post. I don't know if you can see that. It's pretty small. You see the 2 there on the top, or the 2 wipers. They come out to the middle, and then these ones here on the right hand side, they go on the resistive tracks. So on the outside we have open circuit. Supposed to be 250K. Well, let's try this then. What's this one? won't open as well. Oh, okay, I see. So this one here, what did I can't read that. What did it say? This one here goes around. Okay, so that's our 0 ohm track on the outside. Can you see this? I hope so. So this one on the outside is our 0 ohm track for one of the two channels. So you connect there. We only got about 6 ohms. Now if I go inside from here to here, I should get 250K. $226. And then this one here would be our other one. And that goes from here all the way around to here. $204K. See, there's quite a bit of imbalance there. And then this one is our 0 ohm track for inside. It's actually not the greatest. Okay. So what do we do? I think what I'm going to do is I'm just going to clean this as best I can. And we're going to treat it, put it back together, and hope for the best. So, let's get some alcohol. Yeah, bringing carbon off. Alright. Don't want to bend those fingers, because once you do, the pot's pretty much garbage. Alright, now we need to treat. Let's see here. How's this thing looking? It's got sticky grease in it. It's got a kind of a copper spring in there. That's the center detent there. You can see it. There's a little nub, and it fits into a little recess here, right there. Oh, no, you can't see. It's all black. But there's a little recess there. You show it right there, and that's your center detent. And then the sticky grease is for viscosity, so that you can turn slowly. You can feel the detent. It hits the stop there. Stop there. We don't need to do anything with this. I'm not going to take it and relube it because it's already good. So I am going to treat this with the fader grease. This is DFG 213. Lubricant for conductive plastic faders and controls. Now, I'm really not certain about this stuff, if this is okay to put on the conductive track, or if this is just a sticky grease for lubricating the internals. Let's see here. It's consistency of, well, I don't know, but we're going to do it anyway. We're going to put it on here. We're going to just get the smallest amount on there. We're going to leave it like that. And reassemble. Now I can't remember how this went. That's center. Okay. If that's center, then that's the top. Goes like that. And we have our backing plate. I think it went like this. And then we squeeze this and we fold those over. Let's see how I can do this. Feels good. Nothing crunching, nothing broken inside. I'm going to leave that like that. I don't think you can do anything for the resistive tracks. It's just going to be what it is. I can try looking online to see if I have another, I can buy another potentiometer. I think that's what I'll do next. I'm just going to go check and see. It's 250K. I don't know if you can read the text in behind there. I should have shown you before I put the back on. It says 250K CX2. So it's C taper times 2. So there's 2 potentiometers in here. Alright, so I just did a search on AliExpress and bang, you get a lot of these come up. This is a pretty common style. This is called type 161. It's called a double horizontal single row potentiometer. So it's got a single row of leads, it's a double potentiometer, and it's horizontal. So it sits like that, and it's yeah. But problem is, I can get 10K, I can get 20K, 50K, 100K, but I can't find 250K, which this one is. So I'm not really worried about that because this is quite serviceable. You can open it up, clean it, and relubricate it, put it back together, and it should be like brand new. So I'm going to pull the other two. I got the treble pot and the balance pot and probably the volume pot. I'll take them out too, and I'll service them as well. And then we'll be on our way. Next I'm going to do this. I don't know if you want to watch me do this switch. This is the loudness switch, and it's got really, when the switch is out in the non-loudness position, you get a lot of contact resistance on these two. But when you push it in, these ones are fine. So I'm going to take this switch apart, give it a masterful cleaning, and it's going to be like new again. I think I actually have these in stock. I don't know. These type switches with the long legs. We'll see. We'll get this one going. We'll fix this one up, and then we'll put these all back in. Okay, I went online, did a little bit of research about this stuff, this deoxide fader grease. This is DFG 213. It says 100% grease, but it's got other additives in it too, I'm sure. Contains silicone grease, additives, and no particles. But they did say it was safe for the conductive surface, the resistive tracks, so it's okay for putting it on there. But they're very clear. This is not a cleaner, right? You have to clean the surfaces with something else, either alcohol or a contact cleaner of some sort. And then this is necessary for lubrication, and it helps with keeping the contact. It says replenishes and lubricate conductive plastic fader switches, potentiometers, and other sliding surfaces. So it helps with keeping the surface clean and keeps that contact there. So this one's done. I'm going to put this one back in. I'm going to pull out the other ones and treat them the same manner. This switch I disassembled and treated with, first I treated it with 401B in a cotton swab, got in there and scrubbed the surfaces where the contacts are. And then I added the D100 and reassembled the switch. And this switch is now, if I measure the switch contacts now, it is down around 15 milliohms, I believe. 13 milliohms. So when the switch was out in the normal position, that's where we were having a failure. It's not when it was pushed in. Pushed in, it's 15. This side is 12 now. See, it's actually improved. When you work the switch, it improves. The side here is, let's try this side. This is 17 on that side, so not quite as good. But it's good enough. It's going to work. Also, this relay, this is 800 grit. I cut a strip about 4 millimeters wide, and if you can actually slide it down in between the contacts. Let me try the other side. Slide it down in between the contacts, and then you can close the contacts with your finger like that, and then just give it a little bit of wiggle, like that. And that removes all the oxides on the face of that contact. These are silver button contacts. They're not plated, gold plated, I don't believe. I don't see any gold plating on these. Let me have a look. Yeah, there's no gold in there. So it's a high current contact, so it would be silver button. So you just do this, about that much, just to remove the oxides. And if I test this one, it came out really well. I was surprised. So we don't have to replace it. Let me get my power here. Okay, what do we have? We've got 8.5 milliohms on that side, which is perfect. It's like a brand new relay. 8.7 milliohms. So what I'm going to do now is I'm just going to flush out any of the stuff that I sanded, any dusts or anything that from the sanding. I'm just going to flush them out with a zero residue and just give it a little bit of that just to flush it out, and I'll let that air dry, and then I'll put the lid back on and we're done. And whatever you do, don't mix up the bass and treble pots. This one's a 250K pot and this treble pot is 100K. This I can buy online. This one I couldn't. I couldn't find a 250K pot, but it doesn't matter. We're going to put them back. Just make sure they go back to their correct location. There's probably a difference in the circuits. If you got these mixed up, you probably wouldn't sound very good. It would probably not work very good at all. Alright, so I'm at the stage of putting things back together here, so just want to get this going. Really, I'm kind of at a loss as to why this thing sounds so terrible, and can't really figure it out. I did a lot of testing. I tested all the output devices and the drivers for, gain and make sure everything's good that way, and everything seems to check out. So there's really no excuse as to why it's sounding so crappy. The caps weren't a good excuse either. Like they seemed fine enough for the circuits. There was really no bad caps that jumped out and made me think that, oh, this is a smoking gun here, or this is the problem here. They all seemed okay for the most part. The only part I did find troubles was in the tone circuits. The bass and treble potentiometers are pretty much, they should actually be replaced because they're way out of tolerance. The let's see, for example, the treble pot is a 100K pot and it measured somewhere down around 75 or 77K, but it was both channels, so the variation between the two channels wasn't that great. But I don't know, I'm just guessing here. But so I'll finish putting this all together, and then we'll do some power ups and some testing. I'm really trying to get a handle on when this thing was built, and from what I can tell, it looks like it's 1990. Not really sure, but I have this memory retention battery here. This is a lithium battery, and it's a CR2430. 2430 is the dimensions, and it's a lithium, what is it? Made, can't read it. Lithium cell, 3 volts. Okay, these are typically about 3.2 volts when they're fresh. Let's see what we got here. Yeah, about 2.6. The cell's pretty tired. What I'll do is I'll order a new battery. If this thing's 35 years old, that's pretty amazing. But lithium cells will last that long if you take care of them, if they're treated properly and they don't get high discharge. You know, all it does is it keeps the memory alive. So yeah, I'll order a battery for this. Probably take a couple weeks to get here, but by the time the battery gets here, I'll be done my bench testing of the listening tests and stuff. So I'll pop a new battery in there and we'll be done. Yeah, and just a correction, 2430 is 24 millimeters diameter, 3 millimeters thick. So that's what 2430. And it looks like my assumption of 1990 might be correct. This LED looks like it's got a crack on it. Cracked solders. So I'm going to solder this back up. I wonder if this light was blinking. Or intermittent. So that's good. Now this gets wrapped around the shaft like that, and then the knob goes on. This gets fed through and connected on the board. There's a little spot that says LED. Alright, so let's do our initial power up. Everything's back together. Let's turn it on. And we are greeted with lights and click. Alright, now I have to set up the bias. I have to let it warm up for, it says 3 to 4 minutes. And then we want 4 millivolts across the test points. There's 4 test points on the board. They're up against the heatsink. Test point, let's see here. Test point 3, 4, 5, and 6. They're up against this heatsink here. So I'll let this idle for a bit and then I'll connect my voltmeter and we'll do that. Alright, it's been on for about 5 minutes now. Let's go in and make our adjustment. This is a little bit high. Wow, that's touchy. Let's do some of this. Wiggle, wiggle, yeah. Okay. There. Yeah, it's good. Do the other channel. This side a little high too. Turn this one down. I don't know why they have such a low amount. Okay, so what does that do for our consumption? We're down 22, 23 watts. And like usual, when I start test driving these and I put on the listening bench, listen to them for about 2 weeks, I always monitor the power consumption with a meter just like this as I do that, and I will always watch the power consumption. If the power consumption creeps up, or go back in and readjust these. So it's not a big deal if it's spot on or not. Alright, I think I'm done. Let's connect it up and do some testing. Alright, let's do our 10-minute power test here. Get things underway so we can get this off the bench. So let's turn it on. I think I'm all set up. I believe so. Let's turn it on. I adjusted the bias, and power consumption is stable around 23 watts at idle. And let's see what we have here. Do we have any signal? Oh yeah, there it is. Let's turn this up and get clipping. Right there's our clipping. Clips a little early on the right channel, bottom trace. We'll set the top channel to right there, I believe, and we'll leave it at that. And we are at 21.40 watts, volts RMS. Start our timer. I think you can see that, and we have 206 watts going in, some watts coming out, the rest will be heat. So I'll bring you back in 10 minutes unless something happens sooner. We're 4 minutes into this test, and I'm seeing something I'm not happy with. This bridge rectifier is getting quite hot. It's over 100 degrees Celsius right now. See if I can get a reading on it. Cable in the way. Yeah, I'm getting 101 degrees Celsius on that bridge rectifier. That's not cool. I don't like that, the way they have this bridge rectifier. It's just a little module that they stick in the printed circuit board, solder it down. It should have some better heat sinking or something. But we'll keep going. If that thing blows up, we'll have to replace it. Until then, we're just going to have to hope it holds out. We're at 5 minutes now, and staying at around 102 degrees, 103. I'll keep an eye on it here. I also notice as that bridge rectifier heats up, we're losing our rail voltages. They're slowly dropping down because we're at 106 degrees Celsius on the, and we're losing our rail voltages, and we're starting to get clipping, which means we're losing a lot of heat through that bridge rectifier, a lot of energy. Let's keep it going. We're at 6 minutes now. See if we can hold it for 4 more minutes. Yeah, we're getting dangerously close here. This is 7-minute mark, and we're almost at 110 degrees Celsius on this. I'm just going to shut it down because I'm scared. We're losing our rail voltages. So it probably could benefit from a upgrade in that department. Let me show you what I'll show you after. But for right now, we're going to conclude this test at 7 minutes. Heat sinking is pretty darn warm too. I think we are putting out over 50 watts a channel, and this thing is rated. Let's see, it's rated at 37 watts per channel into 8 ohms. This thing can probably do 37 watts all day long, but dynamic output power 55 watts per channel into 8 ohms. I think that's where we were reaching that 55 watt mark, and that's just a little too much for this. It's just not designed for that level of heat and power dissipation. So yeah, I like Nakamichi, but I'm starting to see things here. So let's do some square waves. Let's turn down the power to about 1 watt, and we'll do some square waves. Alright, here's a 1000 hertz tone. Let's go down in frequency. $100 hertz. $90, $80, $70, $60, $50, $40 hertz. And quite a bit of tilt on this. 30, 20, 10. So yeah, I don't think replacing caps made any improvement in that department. So let's go back up to about 100 hertz. Let's go back up to let's go back up to 1 kilohertz. We'll try these controls. Bass, cut. Yeah, see. Control is still acting weird. It's like we have no range of control between 9 and 3 o'clock. I can spin this all day long and it makes no difference to the signal. Treble cut. Treble boost. Loudness. Pretty typical. It's working better than it was before. Okay. Our balance left and right. Looks good. Let's go up in frequency. Ten kilohertz. 10 kilohertz. Not the fastest amplifier I've seen. We lose it right around here somewhere. This is 24 kilohertz. Okay, I think that's probably stayed the same as it was before. Amplitude is good though. It's not. Okay. It does have its limitations. Although it is a budget amplifier, a budget receiver from Nakamichi. This is the Receiver 3, which is the lowest power one. Now, the Receiver 1 and Receiver 2 both have higher power. They're a bit more built. This one is built more down to be a budget receiver, I believe. Yeah, there's the bridge rectifier there. It's getting screaming hot. It was over 110 degrees Celsius. Yeah, I don't think that's a good solution for this amplifier. You need something a little more substantial. But it does do the business. People don't listen to music at full volume for extended periods of time, so it is adequate for what it is. I just think they could have done better. As this heated up, I think we lost our rail voltages. They kind of were sagging because we get, as it heats up, you get more and more loss through your PN diode junction. So yeah, I think they could have done something better there. So this is the KBL02 that we're using. It's a 200 volt bridge rectifier, 140 volts RMS. Now this is what I was concerned about, this tempered junction maximum, 150 degrees Celsius, and we were already at 110 reading on the outside of the case. So 40 degrees, we would have been, like the junction temperature is not the same as the case temperature. Got to remember that. So there's a temperature gradient there, and there might have been a difference, but 40 degrees Celsius spread, I wasn't happy with that. Current, reverse current's 5 microamps, but when we heat up the diode to 125 degrees, our reverse leakage current climbs from 5 microamps to 1 milliamp, which is also another thing that's detrimental. Junctions, operating junction, yeah, 150 degrees C. So we were just about there. I think if I would left it for another 4 minutes, I think it would have blown up. Hard to say. Never know. Some of these diodes are pretty tough, so. But I think they could have done something better with this. Even if they used 4 separate individual diodes, then they would have air circulation, and they would have been cooler than this all-in-one package. Okay, here's a look at the parts that went into this. Aside from the backup battery I haven't got yet. I ordered it today. I expect it here in 2 weeks. So, but these are all the caps I replaced. Now, for the most part, these caps are fine. I don't expect replacing these caps made any difference in what I'm going to talk about here. But this probably helped a little bit in with regards to frequency response. I did have an improvement in frequency response over the baseline tests that I did, but they were pretty minor. We're talking like 1/10 of a dB, 2/10 of a dB improvement to make it flat. For example, here I have negative 0.6, and here I have negative 0.5, negative 0.2, negative 0.1. So a little bit of increase Would anybody notice that difference? No, I don't think so. The biggest improvement came in the distortion figures, and here I almost have like 0.5%, 1/4% distortion, THD, and now after the work it's down by a magnitude of 10, so it's dropped. So for example, I have 1000 hertz on the left channel. I had 0.4% distortion, and after the work it went down to 0.024%. So quite a huge improvement. Now I think that was only because of that speaker protect relay was dirty, and when you get a dirty speaker protect relay, you're going to get all this distortion. Doesn't matter what you can do, you can't put clean sound through a dirty relay. So it actually cleaned it up really nice. It's and compared to the factory specs, distortion should be less than 0.1%, and we are down a magnitude below that in pretty much every measurement. So it was a good result. Now I did listen to this on, well, let me get rid of this stuff. I'll talk a little bit more. All right, so let's talk about this receiver. I just listened to the FM on this before I started the camera up, and it sounds flat. It sounds, you know how when you have your speakers out of phase and you just have that lack of depth and bass? That's what it sounds like. But you saw and I saw on the scope that both channels are in phase with each other, so they're good. But it does have a problem with a flat sound. You have to almost run in this thing with the loudness switch turned on, otherwise it just kind of But I'm going to put this on the bench and listen to it for a while. I'm not sure what's going on with it. The bass control, really, you can't hear any difference in bass between your 9 and 3 o'clock positions. It just all sounds the same. Treble, on the other hand, works. These two potentiometers have issues with they changed in value from when they were new. The treble pot, for example, is 100K, and I measured it down around 75K. So they have changed in value. So I expect that is part of the problem with this, because these tone controls are in the feedback loop of the amplifier. All right, so I think that's what's going on here. Nakamichi had these built overseas in Taiwan, and I don't think they got their money's worth out of the Taiwan factories. I think a lot of shortcuts were taken. The design might be very good, but I think the build quality is not all there. It could have been better. But it is still a good receiver. I do like it. I'm going to listen to it for a while here, and we're going to see how it does on the bench. So, all right, take care, and we'll see you on the next one. I have lots of stuff coming up. I got a couple turntables, a couple cassette decks I want to do, get those out of the way, and more receivers. So stay tuned. There's lots coming. Alright, so it's 3 weeks later, and the batteries have finally arrived. So let's install them now. I have the iron warmed up, and we can get this battery replaced. Now, I did listen to this receiver after I finished, and it sounds pretty darn good. I'm impressed with how it sounds. The bass control is very whacked, because you have a range where there's no control over the bass going either up or down, and you have to rotate it from, like I said, between 9 o'clock and 3 o'clock. There is no change in the bass. So yeah, but it does sound good, and I think it's got lots of bass when you are listening to it. It's got enough. It's got your average amount, and I think if you need any more, you can always turn the loudness on. I don't think that's necessary though, because it sounds just like any other receiver I've heard, and there's really no problem. But hey, what do I know? Just a little bit hanging on here. There we go. Alright, so positive, this side's positive, this side's negative. Let's see what we got here. These aren't exactly the same. But they should be fresh. Positive goes that way. It doesn't look like it does not have the same pin layout. If I get one of these out. You can see the difference here. So I'm going to have to get creative or something. Positive goes this way. Negative goes this way. I might have to bend a pin. Yeah, I'm going to have to bend a pin a bit. Let me see if these are even good batteries. I'm going to install a dead battery, then I'd be wondering what's going on. So what do we got? 3.3 volts. That's perfect. That's a fresh battery. You see my dilemma is here. The spacing of the terminals is not the same. But we'll work through it. We'll power through this and we'll get it. Oops. Well, if I break it, I got 4 more. So this here goes here, and this one goes there. There we go. It's not going to look pretty. I got it backwards. Yeah, that'll work. It's not completely straight. Okay, good. Job done.